Hi, everybody. Welcome to the NVIDIA Omniverse live stream. Very excited to have this show with you today. Today, we're going to be focused on industrial inspection with OpenUSD and AI. And also, as a double bonus, the presenter is actually Nandu from our community, who also has been managing the OpenUSD study group in our community on the Discord server. So the first part of the show will kind of focus on Nandu's company's work, leveraging OpenUSD for industrial inspections, actually. Pretty exciting and a great use case for OpenUSD workflow. And then the second half of the show, we have a couple of special guests joining us to talk about OpenUSD, the resources available, the study group, some tips and tricks for getting started. So hopefully you'll be inspired by some of the work you'll see presented today. If you haven't already gotten started into OpenUSD, and you'll be able to learn how to do that in the second part of the show. I'd like to also ask everybody, if you're new to watching this live stream, welcome. It's so great to have you here today. Please introduce yourself in the chat. It will be just fantastic to get to know some of the viewers a little bit. Feel free to let us know what industry you're in, your name, if you have a link to your portfolio site or your company website, whatever you feel comfortable sharing with the rest of the community. That is so helpful, not only for other community users watching and networking with each other, but also for us, so we can kind of see who kind of might need, what industries and companies might need more resources based on your participation today. Speaking of which, also use the live chat for ask your questions and post any comments along the way. That's what it's there for. Our producer Amelia is here watching the chat very carefully, so we'll be posting links throughout the hour. Okay, so before we introduce our special guests, and also one quick note: this live stream is available on YouTube right after this. So if you came in late, or you know someone who could benefit from this live stream will be available on the YouTube channel for NVIDIA Omniverse directly following this live stream for viewing whenever you like. We're super excited here at NVIDIA because of the Kit SDK v106 release, which is in beta, and the actual official launch, the release is imminent, literally very, very shortly. But you can get a hold of the beta right now. We would love to get your feedback. Feel free to head over to that website, developer.nvidia.com/omniverse, for more details. Lots of improvements, as you can see on the screen, including with RTX rendering. We also have amazing content available for free and paid, revolving around Omniverse and OpenUSD. Amelia is going to post a link for this in the chat as well. I highly encourage you to take advantage of the sessions that are available on Video On Demand, not only from GTC, but that we also are released throughout the year. It's a really powerful training materials that you can take full advantage of. Lots of exciting things across the world. The next couple of stories are specifically about factories, robotics, and digital twins. We have a very special guest later on in the hour whose own company dives into this and has been a great part of that story. We have a link that we'll put a blog regarding NVIDIA AI and Omniverse and robotic factories. So feel free to check that out. And as always, discuss any of your thoughts on this stuff on the community Discord server, which is discord.gg/NVIDIA Omniverse. Again, the second story revolving robotics and autonomous machines. We have a great blog post here. We're going to post and share in the chat. Again, if you miss any of this stuff, it'll be in the description afterwards. And the third story regarding training of robots with NVIDIA AI and Omniverse/OpenUSD. We had this live stream several weeks ago now, but you can look at this complimentary blog as well as a live stream for some chat with the developers from SoftServer and Continental. Really fascinating story how they leveraged OpenUSD and generative AI for their use case and a digital twin of a prototype assembly. So feel free to check this out as well. Like I said, there's also a live stream on it. And we would love to help those out there who are wanting to get more into OpenUSD, how to take full advantage of our newest learning journey, we're calling it. Learn OpenUSD. It's going to be available very shortly. The team's just finalizing a few things. But if these OpenUSD stories and this workflow is of interest to you, I highly recommend signing up for the link that's on the screen right now, so you can get notified as soon as this is available. It's going to be basically a continuation, or maybe next level of what we have kind of on the DLI right now regarding OpenUSD, which a lot of people found helpful, but we wanted to see a more of a deeper dive. So that's exactly what this does. And NVIDIA Isaac Sim 4.0, a lot of people excited about it. Lots of amazing features that have been added, improved on, optimized. I hope that everyone who's an Isaac developer is taking a look at this right now. It's developer.nvidia.com/Isaac Sim. If you have any questions on this, we also have 2 areas you can go for support. One, the official area where developers are. That is the official forums. We'll post a link for that. And we have a specific subforum for Isaac Sim. And then on the Discord server, you can interact with other users who are leveraging Isaac Sim. And both are great places to go. I highly recommend that you go to network and connect with other users on the Discord server. And for bugs and other kind of more official support, definitely leverage the Omniverse forums. I think that does it for our quick news announcements. So I'm very happy to introduce our first guest here. Nandu, thank you so much for joining us. I'm very excited to have you here. You're a veteran of the live stream. You've been on before, but now we're really doing a deep dive into all the great work you're doing, not only with your company, but also with the work you're doing with the community and showing people how to and working together to learn OpenUSD together with sample projects. Really exciting. Why don't you introduce yourself before we bring on the next guest?
Sure. So my name is Nandu Vellal, and I'm one of the co-founders of nAurava Technologies. We are currently working with industrial inspections, and the name Aurava comes from Sanskrit word which means dimensions, and our goal is to build n-dimensional visualizations specific to industrial applications. So industrial inspections, yeah.
Amazing. And about how long ago did you start kind of getting involved with OpenUSD?
Yes. So OpenUSD, I have played around with way back when it was run from command line. It was not even called, before Omniverse was born, the Isaac Sim. So I started playing around then. So since then, I have been building applications. And then, once it became formally OpenUSD, started learning almost a year and a half, 2 years back, specifically the OpenUSD. And also, the NVIDIA community has been, all the developers and the folks on the Discord have been really helpful in, me getting till here in terms of my journey of OpenUSD. So I'll share some of the work that I've done and some of the use cases. Yeah.
Awesome. That's so great. Well, thank you so much for joining us. I'm going to bring in one of your guests here, Dr. Singh. Hello, Dr. Singh. How are you doing?
Hello. Very well. Thank you. Thank you
for joining. Thanks, thanks for joining us. We're very honored to have you here. So, Nandu, do you want to introduce your partner here?
Sure. So, Dr. Singh is also the co-founder of nAurava, and he's a scientist, researcher, innovation coach, digital transformation coach. He is one of the guys who is a pioneer in terms of like when GPT-3 came out. He tried co-authoring a scientific article with GPT-3. So his expertise is phenomenal, and I just can't thank him enough in all his support and help he has provided. Yeah.
Well, Dr. Singh, thank you so much for coming. Do you want to give any more insight into your background?
That's good enough.
Okay.
I'll talk a little bit about myself, and if people like it, they can look me up on LinkedIn.
Okay, that's perfect. And feel free to, Amelia can post your LinkedIn on the chat. If you put it in the private chat there, she'll share it.
Sure.
And we also, so do you want to give more background on yourself before we share a LinkedIn link?
I'm into my third career. I'm a former professor of aerospace engineering and a former R&D executive for Alstom Power. 10 years ago, I started coaching innovation and digital transformation. COVID gave me some time, and I sat down, wrote a few books. There are about 20 of them on innovation and transformation available on Amazon.
Oh, fantastic. All right. We'll definitely need to get those links in the chat. Super exciting to have you here for this conversation. And we have another great guest from the community. Please welcome Kai to the live stream. Hello, Kai.
Hello. Great to be here.
Well, thank you for coming. And so your participation is also very special because you're a long-term member of the community as well. very active on the Omniverse Discord server. But do you want to introduce yourself a little bit?
Yeah, thank you. I'm from Schmalz and I'm a full stack developer. My journey with Omniverse or OpenUSD began with Isaac Sim back when it was part of Unity. And I took the journey to Unreal Engine, and now Isaac became part of the Omniverse.
That's amazing. And you've also been one of the great participants in the weekly OpenUSD study group that's on the Discord server, which is fantastic. We're going to dive into that study group and that work a little bit later on live stream. But first, okay, so now that we have a good handle on everybody who's here, I want to just, for everyone watching, feel free to post your questions or comments to any of the guests here in the chat, and we'll do our best to keep up with them. So Nandu, let's get into things here. I would like to learn more about what industrial inspection is for those who might not be familiar. We've covered this topic a couple of times from a couple different companies, but tell me in your words, what does industrial inspection mean?
Sure. So essentially, anything and everything that humans build need to be inspected, at the time of manufacturing, as well as once it's in service. So you want to make sure that the assets, the physical parts, all of those, whether it be bridges, planes, ships, whatever it is, you want to inspect them and make sure that they are fit for service. So, and there are a dozen or so techniques that are available, or more than a dozen or so techniques that are out there, using which you inspect these, and then the inspectors determine whether they're fit for service, inspectors and experts, right? So that's kind of like the industrial inspection at a broad range. So what we are going to talk in today's session is about some of the work that I have done in terms of like ultrasound inspection technique, which is a specific inspection technique using ultrasound. So the good thing is it's a lot easier to understand industrial inspection if you understand a human body. So we always compare industrial inspection to medical technology. So medical technology, you have X-ray, you have radiography, CT scan, MRI. So you use those to find out what are the problems and challenges that are there, with human body. So something similar happens for industrial assets, where you use various techniques, including X-ray, CT scan, and MRI, to find out are there any problems with the assets or the fit for service. The problem is that if they fail when they're in service, the consequences could be massive. So and we can't afford those failures, and that's the reason we perform these inspections. So
interesting. Okay, it's really fascinating, and I know we're going to get to your slides in a minute when you go into more details about your company. But just from a high level, so how do you normally work with your clients, or do clients come to you and say, "Hey, we need your help in inspecting our site or our machinery for different defects"? Is that how it normally works?
Correct. So, we ourselves don't provide the inspection services. So there are a lot of inspection services firms around. So we work with those services firms. So there are inspection service. So with these inspection services firms, because as the newer technology is coming in, so we are kind of like the enabler of them to adapt some of these technologies. So to help them, whatever the data that they capture from these inspection procedures, how can we take the data? How can we help them analyze? How can we help them use it for downstream applications, whether it's digital twin or for training purposes? So we are more of an integrator, where we provide them the next generation tools and technologies. So that's what our goal is. And we attend some of the inspection specific events, and talk to a lot of these inspection services firms, and a lot of the big asset owners, like chemical plants, right, or oil and gas plants. So that's how we seek our customers. Yeah.
Very interesting. And so obviously digital twins is a massive part of this, because you're basically, anytime a company's making a digital twin, they have that data there, and you guys are working with OpenUSD to really take full advantage of that. Okay, so do you want to share your
Sure.
slides?
Yeah. let me share my screen here.
And then Nandu also provided a bunch of great videos to go along with these slides. So you guys are in for a treat. A lot of great work went into prepping material today. So feel free to ask your questions along the way. Right. Here we go. Okay, cool. Industrial inspection with OpenUSD and AI.
So yeah. So the other thing is we're also an Inception partner. So just wanted to mention that.
Yeah, so for people who don't know what Inception is, Inception is NVIDIA's starter program. So if you're watching this program and you are a part of a startup, and the definition is actually relatively loose, it only have to be started within the last 10 years, then you could be a candidate for NVIDIA Inception. Maybe we'll play a video towards the end of the live stream regarding what some of the Inception program entails. But really fantastic program, and congratulations on being accepted. It's fantastic. Lots of great free resources for Inception members available.
All right, thank you so much. All right, so a little bit about what's on the agenda for today. So we already discussed a little about the industrial inspection. Some of the key things that I want to share today is like how 3D visualizations and AI can enhance industrial inspection, and what role does OpenUSD play in all of this. And as Edmar mentioned, the OpenUSD study group initiative as well. So just a high-level overview of who we are. So we offer Industry 4.0 strategy planning and consulting services. Some of the technology solutions that we are building for our partners are like remote inspection tools and technologies, immersive 3D visualization applications for desktop, AR, VR, XR, and hopefully soon for the web as well. And also some specific like process inspection process digitalization services. The training, inspector training is a huge piece, so applications around that. And specifically also on 3D visualization and characterization of damages as far as the inspection is concerned. So here's our team. So I focus mainly on the 3D visualization. So that's kind of like my forte. And Dr. Singh, he's an innovation coach as well as a guide, mentor, everything in terms of what kind of projects and services that we can build. And my other colleague, Dr. Shyam, who is in Bangalore, India. So he is this industrial inspection expert. Is more than close to 40 years of experience working across different industrial sectors like nuclear, oil and gas, and aerospace. And just a little bit about the Sustainable Development Goals on UN. So our focus is to build tools and technologies that can enable companies to effectively and efficiently maintain their assets, and how we could train the next generation workforce to adapt to these changing times. So Edmar, you can roll the first video. So talk a little bit about the inspection procedure.
Okay, so here we go. This is video number 1.
So what you see in this video is an inspector is performing an inspection using ultrasound. So he used a couplant to ensure there is no gap between the ultrasound sensor and the part that he is inspecting, so that ultrasound can effectively propagate within the part. And once he scans the part, so he sees the signal on the instrument, and he interprets whether that particular indication that shows up, is it really a defect, or is it some kind of an anomaly? So how do we that's his that's the training that he undergoes to figure out how to interpret those signals.
Very interesting.
So that's kind of like just like a high level overview. So I want to talk a little bit about we already touched upon what industrial inspection is. So the idea here is like how can we find out the defects that are internal to various industrial parts, right? So so it's not just the internal, but also external. Now, a lot of the external defects are hard to detect with the naked eye. So there are specific techniques, and also like on mission critical systems, the even minute cracks that are invisible to naked eye could be a problem once that asset is in service. Think of like a fighter jet that's flying, right? So hence there are all these inspection techniques that are available to ensure the assets are can be in service. And I also put a web link for nd-ed.org. So this is a great site from Iowa State University for somebody who is just learning about industrial inspection. So please check that out. Dr. Singh, it's your slide now.
Oh, so you're just
You
unmute yourself.
are on mute.
Sorry.
There you go.
So all these examples that we talked about inspections, and I think we understand ultrasound, we understand radiography, but let's go back to where the whole inspection thing started. Humans have been inspecting artifacts for years, hundreds of years, and we have mainly used our senses: eye, nose, ear, touch, smell, whatever, right? And then a time came, and this was even pre-industrial revolution. Then when the industrial revolution happened, we started building steam engines, and then we came up with pressure vessels, and we had a pressure vessel burst, and we said, okay, we need to look at these vessels a little bit differently, things that we cannot see with the naked eye, because human eye and ear has a capacity. Nandu, click. So we came up with other inspection methods where we could highlight the surface, whether it's using a dye, or it was using a regular stethoscope or a magnifying glass, so that we enhance the human capability to see what is happening on the surface, being able to see damages smaller than human capability. Nandu, click. The next thing that happened was we said, well, another revolution could be if we can find defects that are not on the surface, that are hidden. So ultrasound, trying to find out what's happening inside the body, X-ray, what's happening inside the body. Being able to go deep into the structure was the next revolution that happened with inspections. Click. And then came the time, 1970s, computers became popular, everything went digital. So the X-ray went towards digital, the CAT scan became digital. We said, let's inspect things and look deeper inside, but then capture the data digitally so you can share, you can analyze, you can do all sorts of gimmicks with the digital data. Click. The next revolution that we are at the moment, the so-called Industry 4.0, that changes the game again when it comes to inspections. What we are trying to do now is, if we have enough data about having inspected thousands of similar parts with different usage history, and all of that history is captured on a digital twin or a digital thread, now can I use the same instrument, whether it's X-ray or ultrasound, to be able to see the defects that are even smaller than the capability of the equipment? Essentially, we are betting upon providing almost sixth sense to the machine to be able to detect subcritical damages on the digital twin. Whereas the equipment still gets faint signals, which is mixed up with the noise. But the fact that you had so much data about other inspections and so much history about this particular part, that you are able to see even smaller defects on the digital twin before you can see it on the equipment. So that's the next revolution. Nandu, click. And we call it almost like sixth sense, the extra sensory perception, which means all of your sensors put together are seeing something, but when that is combined with the data, you go take your inspection or perception to a whole new level. And this essentially is taking two significant technologies that we need to bring in. One is AI, the analytical AI, not the generative AI, which can put the data together, and enhanced visualization so that we can see the damage on the digital twin for which otherwise the signal is still lost in the noise. So that's the next revolution that Nandu and I are focused on, being able to see things which are so small, so early in its life. Thank you, Nandu. Back to you.
Thank you, Ruby. All right. So, however, the inspection industry is facing numerous challenges today. So, the experienced inspectors are retiring. There is not enough people entering the workforce, and there is advancements in both materials and products, as new products and new materials are brought to market almost on a daily basis, and which requires newer inspection techniques and procedures to be built. Adding to that is the dearth of high quality training programs, inspector training programs, and the inspectors also must adapt to all of this next generation Industry 4.0 technologies. So these are some of the challenges that we are trying to address. And I will walk through an example of one of the case studies that we work with our partners, NDT Spot, Sonatron NDT, and Nyholt NDT. So this is specific to flange face corrosion. Now, flanges are significant parts in chemical industry, oil and gas, because flanges connect all the piping to various equipment, whether it be heat exchangers, so whatnot. And so the idea here is we use inspection techniques using, for example, ultrasound to detect as the assets are in service, to detect is there any corrosion that is taking place at the interface of these flanges. So if there is, then you want to take the mitigation action immediately. So ideally, so when the inspection is done, so either is done manually, or there are now semi-automated and manual scanners, handheld scanners that inspectors use. And as the ultrasound propagates, it detects the corrosion at the interface and is interpreted as a signal for the inspector, who then interprets and then determines whether is it okay or not. And when the signal is interpreted, so the current generation of instruments provide some kind of a heat map, what we call as a C-scan. So the orange and red parts are where more corrosion has taken place, and the other areas are okay. So with this information, and these assets are inspected 9 months, every year, so at a regular interval to determine how the corrosion is progressing. So what I have done is taken one such sample, and I have built a use case using Omniverse. So how can I build the visualization to say how corrosion is progressing on a regular basis, as long as I collect the data from these inspection procedures? How is the corrosion progressing? So I'm just going to show you using Omniverse how I have built this application. So here is the application.
We don't see it yet. We don't see it yet. We see a really nice saltwater background.
Okay, so should I stop sharing and start? No, maybe.
You can try that.
Yeah, let me.
It's so fascinating though, and you could I could tell already the significant reasons that you would need to do this on a regular basis, depending on the. Okay, I think I see it now.
Do you see it now?
Yes. Yep, we got it.
Okay, so now this is I have built this application using Omniverse Composer. Now this is not a custom app, so this is just a simple prototype application. It's just a USD file at this point, but this can be easily converted to a custom app if need be. So down the lane. So what I'm showing here is like a simple flange. However, as I use a custom slider here, so you can see that So let me just zoom in. Now this is all in 3D. So so you can see I have mimicked the procedure of like as and when I scroll the slider, so you can see how the corrosion is progressing, right? So the way I'll talk a little bit about how I went about doing this. So I let me just switch back to the slides. So probably have to reshare.
And feel free to ask your questions along the way if you're watching. It's really interesting material.
So
yeah, we can see it now. Yep.
You can see the slides.
The demo. Yeah, we're looking at the demo slide.
Okay, so the demo slide. Good. Yeah. So the way I built this application is I took the CAD of the flange, and then using Blender, I extracted the surface of the specific surface on which I need to depict the corrosion information. I converted from a typical mesh comes out as a triangulated, a tri-mesh. I converted it to a quad mesh, and then I built these variants. So the idea of variants is that for each time series, for each time, meaning like for say 6 months or a year or 2 years. So for each of those duration, I have just the specific overlay with the defect information, and I'm not replacing the entire CAD. So what this does is this goes back to the OpenUSD concept of non-destructive edits. So I'm adding a layer on top of an existing part. However, from a user perspective, it's seamless. So they see that when how the defect can grow over a period of time. So they have that visualization that gives them the capability to kind of like do any analysis if they want to do. Now, there are a few caveats in this one, in the sense that when I created the mesh, I didn't go for a fine grain mesh. I kind of like just took a rough order of magnitude of the mesh, mainly because my laptop cannot handle all the finer details. So, but this demonstrates that using OpenUSD and Omniverse, I can build applications for analysis that can be used by inspectors and experts. Okay.
It's amazing.
All right. So, okay. So now we talked a little bit about industrial inspection, and then like, where things are heading is that we see that already, like, in the previous one, I just showed a little bit about like how we use like a C-scan, which is just a 2x2 or a XY grid with a heat map. So where things are moving is like already some instrument manufacturers are able to provide a voxel grid, which is 3D. So imagine if I can bring the 3D data into my digital twin of the defect. So we can build all kinds of, like, say, fracture mechanics, finite element models to provide a better predictive failure mechanisms. Additionally, the entire inspection industry is also going through a change in terms of, like, how to represent all this inspection data so that it can be used for downstream applications, like whether it's digital twins or custom applications. So all the way, for all the inspection techniques. So there is a the standardization of the data formats is happening. We hope it could be like HL7 format or some kind of a JSON format, which we should be able to bring it into USD and Omniverse. So there is also a significant opportunity here, specifically for OpenUSD, in the sense that when we inspect some of these assets, specifically, for example, a rail that I'm depicting here. So the inspection technique, there could be multiple inspection techniques that is used on a single part. Like in this case, you use ultrasound to detect internal defects. However, ultrasound cannot detect the surface defects. So you use eddy current technology. So now what happens is, for us to depict in a single asset, if I want to demonstrate or show both the information, then I need to do like a data fusion. So I want to bring in both the data, because to get a clear picture of the health of the asset, I want to look at all of the data, right? So there are these kind of opportunities that will be emerging. So, all right. So the next set of videos, Edmar.
Okay, you ready for video number 2?
Yes.
Okay, here we go.
All right. So here, what I did was like I created a visualization where I'm bringing in data from 2 different ultrasound sensors, right? So in this, so okay, so this is the other one where you're using. I'm using virtual reality, the augmented reality capability provided by the Omniverse, where I can show how the defect is registered, right? So I hope you can see my screen now, right?
Let me
So
see. Let me show your screen again. There you go.
see it?
Now we see the slide. Yep, multi-sensor data.
Okay. So yeah. So essentially, so the capabilities already exist within Omniverse, where I can bring in data from multiple sensors. And the other thing is, with the now OpenXR capability of Omniverse, we can build AR, augmented reality application, where we can show how, when these defects are using the equipment and using the inspection equipment, and how the defects are registered on a large assets, like whether it's a plane or a car. We can tag those specific areas on these assets, and then we can get a almost like a realistic view of how these defects look like.
That's so cool.
All right, so we talked about the 3D and AIs, right? So we know that the AI is going to get embedded across the board. Now, if you look at a typical inspection process, so there is inspection planning that's going to happen, and subsequent to that, actual inspection is performed. And once inspection is performed, there is data analysis that the inspectors perform to evaluate the health of the asset. And subsequently, that data is published onto a digital twin. And now, once the data is published, we could leverage as part of the training of custom training within an asset owner's facility. So we see a huge opportunity for edge AI, for all kinds of, there are already all kinds of robots, drones that are available, from all the way from performing the inspection. So AI is going to come into play. AI and visualizations are going to come into play in terms of inspection planning. Data analysis, for sure, AI is at the forefront. But our focus is specifically in the realm of digital twin and inspection training, where how we want to build the applications similar to the one that I showed just now, XR as well as AI, combination of that. And what we see on the training side is it's almost like for an inspector, you'll be able to build a personal coach that will be able to say how this inspector is doing, or what are the challenges he has, and then how he can be coached to either identify the defects, or even in terms of any new asset that he needs to inspect, he can be trained. So all kinds of applications will be emerging over the next few years or so. The next video. So this, why is it important to inspect flanges?
Inspecting flanges is crucial for maintaining the safety of the chemical plant. Flanges are the components that help in connecting pipes, valves, and other equipment. Any leakage or malfunction in the flanges can lead to hazardous chemical spill, which can not only harm the workers, but also have a severe impact on the environment.
So yeah, we could rapidly build these training applications, which will enable inspectors to gather all kinds of information, right? So All right. So what are some of the benefits to our customers? Reduced time and cost to perform inspections, better planning by visualizing the inspection process, comprehensive training of the workforce, which finally will lead us to safety of these industrial assets. I know, Edmar, you talked a little bit about how I started my OpenUSD journey. I want to share a couple of these videos.
You ready for me to play this one?
Yes. So
Okay.
this thanks to my former colleagues at Railbotic Systems. So we were ideating on, like, how we can build a robot to perform inspection of the rails, and this was the first application that I built using Isaac Sim way back when it was not even called Omniverse. So yeah, on to the next one. And I and Dr. Singh, we worked on a US Air Force SBIR where we prototyped a VR application. This was built using Unity, how we can show not just the inspection, but also the 3D visualization. So that was significant in the sense that it gave us a lot of ideas in terms of like how the next generation technologies can be utilized. And this is the other application that I prototyped using another NVIDIA partner, Chooch, in terms of like how I can leverage AI or maybe down the lane, maybe even DeepStream to say how to, this is important in the sense for remote inspection capabilities where we can say whether the inspector is performing the procedure or not properly. In this case, I'm just identifying the assets here, but then the real application is to determine whether an inspector is performing the application in a proper method. Is he doing it the right way? If not, the experts can remotely help him. So this is the other application. So I think ready for next video. So this is an application that we built for UGA Technologies, where they provided the hardware, and what you see is that in this hardware, so you can simulate any type of a part that you want to inspect, and the dummy probe will capture, like, say, ultrasound inspection data, and then all the visualization application I have built using Omniverse. So there is a significant opportunity in terms of building these types of applications, and then it gives the ability to try all the numerous use cases that is not possible in a typical lab setting. So
very cool. It's pretty wild. It's wild. Yeah, and it clearly,
all
like,
right.
would you consider yourself an early adopter? Because you've been working on this for a while, and clearly you have made a lot of progress in several different projects, and also with a really eye towards the future. So,
Sure.
what made you jump in at the point you did?
So I think the big problem that we see is like people struggling in the industry, and those that's the biggest challenge. And the question is, like, how can we help the people in the industry who are facing these challenges? There are still some significant challenges and barriers to be crossed in terms of wider adoption of these technologies, as well as the cost of the technology that we can make it accessible to them. So hopefully, as things progress, all of those things will sort itself out, so that we'll be able to bring these kind of applications for a lot more users and the community. So.
Very cool. I mean, I can think of no better person to bring into this conversation right now than the distinguished Michael Wagner, and also Maddie Kodesol from the NVIDIA team. Michael and Maddie, welcome. So great
Hello.
to have you guys here. I don't know if you guys got to catch some of that presentation, but pretty impressive use of lots of technology, but leveraging OpenUSD to kind of connect and bind all the pieces together and share among different applications. But yeah, what are your first thoughts? Michael, you've been working with OpenUSD for your company, SyncTwin. which is enabling digital twins for companies of all sizes. So we'll talk about that as well. But yeah, what were your initial kind of feedback on what you just saw? Oh, we can't hear you. Your mic might not be connected to.
Oh no!
I'm not sure if it's on mute.
Sorry,
it might be.
Now you should hear
there
me,
he is.
right?
There he is.
Yeah, there you go.
Yeah, yep, sounds good.
Yeah, I've talked a lot to Nandu, and he's done a terrific job for this whole inspection and visualization. So it wasn't new. I think it's just great that you can visualize the defects and bring this all into OpenUSD and connect it to the other systems as well. So I think that's great. And I didn't see the virtual reality yet. So that was great to see.
That's very cool. Maddie, what are your first some of your thoughts? You've known Nandu for a while. I think Michael and Maddie, you're both considered from Nandu had told me that you're mentors to him in the OpenUSD journey. So what were your thoughts, Maddie?
No, I'm always impressed by Nandu's work and the other thought leaders here that we have on this call in terms of pushing digital twins and visualization in this way. So it's been really interesting to have those conversations about how USD and Omniverse can best serve to solve those problems that Nandu's identified and is trying to solve.
It's almost really hard to imagine a time before OpenUSD in a sense, even though it's so new, but how complicated and challenging or maybe even impossible some of this work would have been done beforehand with all these different applications using their own proprietary data and basically, losing things along the way when you're trying to do interoperability. So really fascinating. So the other reason why we want to bring you on here is OpenUSD is as I said in the very beginning of the live stream, there's a huge momentum that's been building for well over a year now among many different large companies, including Apple and Pixar, Autodesk, Adobe, many other great companies. You guys have been probably using it the longest, especially Kai, who's also here from the study group. What would you say? So things have changed, obviously. It's an evolving format, I guess you could say, because it's always undergoing some changes. What would you say? So knowing what you know now, and this kind of goes to everybody. We have obviously people watching. We saw in the chat some people from different companies looking at OpenUSD and digital twins. What would you say would be a good place to start? I think sometimes these topics can be very overwhelming when people look, oh my gosh, how do I grab all this for my company? And, I need all this tons of data and all these different applications, but it's really not that complicated, right? You kind of just need to look at what's the bare minimum that you want to try to accomplish and see. But what do you guys think? What's a great way for those companies to get started?
Maybe Kai, go ahead.
Yeah, so I think from my perspective, just get your favorite project and try to get started, because there is no really right way to do it. Just try to make something happen with OpenUSD and the tools you have at hand.
Yeah, and clearly there are a lot more resources now than there were available a couple years ago when you all started diving into it. Maddie, you actually spearheaded the creation of the OpenUSD study group that meets weekly on the Omniverse Discord server. Do you want to share a little insight on, because actually, why don't you introduce yourself also? Because I think people would love to know your background, and it's very related to what we're talking about today.
Sure. So just briefly, I'm a product manager now at NVIDIA, working on USD and moving that forward into the future and all the things that that it does today and what we want it to do into the future. And my background is in media and entertainment. and working at DreamWorks and animated feature films. And that's where I was exposed to USD, fell in love with it, and then came to NVIDIA and was able to more exclusively work on that with Omniverse. And so we started this study group with Nandu and others on the Omniverse Discord that we were we just wanted to talk about USD. I had my media and entertainment background, and I had some experience with USD, but I was really wanted to be able to talk with Nandu and others about their work and how USD could be leveraged for their work. And so that is really where I thought it got really interesting, and we've had lots of conversations about how to make that work.
Well, that's awesome. And so you were actually quoted earlier in the chat by Ordinary Alan. Let me see if this is true or if he misheard you. Maddie has said yesterday, I can really see OpenUSD becoming the 3D standard for AI. Is that true? Did you say that?
I don't know if that was a direct quote, but no, yeah, it's not just. I'm sure I took that from Aaron or Aaron Luke or somebody, but.
But tell me why though. Why do you? Because we've also been talking about OpenUSD as basically, I think it's often said here in NVIDIA that what HTML is for the web, OpenUSD is for 3D and simulation. So why do you think that is?
Specifically, we have some great generative AI around geometry, so like Edify and things like that will generate 3D meshes of objects from prompts or imagery, and but where we want to get to is we don't want that ends up being like a geometric soup of and what we really want is we need labeled and data with attributes that we can then train robots and AIs within those 3D environments, and that's where USD can be this glue, taking potentially any sort of 3D data and assembling that into classified and labeled scenes generatively through with AI. We've been doing it manually, but that could be work that AI would do for us.
Makes a lot of sense. And Dr. Singh, this must be super exciting for you as well, because you've been following the digital revolution, each revolution over many years. So it must be really exciting to see you for you to see this kind of really this huge kind of building very quickly of adoption and seeing how AI is affecting many different industries. Almost overnight, but not obviously it's not overnight, but for some people it might seem like it's overnight, but there's been a lot of people working on this for a long time. Yeah, so how what are your thoughts when you see this work coming together?
You're on mute.
There you go.
I'm actually glad to see it happen. I think this whole thing about revolution in inspections, the concept of NDE 4.0 was coined by me about 7-8 years ago, and since then I've been battling, trying to move people in that direction to see and be able to envision where this is going. So when I see somebody like Nandu comes along and says, hey, now we have tools that makes it possible. Ricky, you've been talking about this giving extra sensory perception to machines, but there was no infrastructure, there was no mechanism to do it, but now we have it. So it's kind of it's fulfilling to see that what we dreamt 10-15 years ago is now coming through and is becoming a reality. So I commend what NVIDIA has done, and I like what Nandu is trying to demonstrate to the community that we've been trying to move. So I'm glad to see it happening.
That's awesome. And Nandu, that's perfect segue to what I was going to ask you next, because so when Maddie got the OpenUSD study group started, I guess the intention was for developers in the community to be able to work with each other and learn at the same time and teach each other and try to have goals for the next week's meeting. Tell me what inspired you to kind of take the helm and manage the group, and what have been some of your learnings over the past year from doing the study group?
Oh yeah. So first of all, like I was as I was learning, I was having difficulty learning. So there were not many kind of like use cases, and then like Maddie pointed me to try the do the install of the Pixar's original OpenUSD, and then use the USD view, which was great, right? So because that has some examples, but then the way those examples are kind of like written, I think a lot of it is done by developers, right? So it's hard for everybody to understand that. So that's a typical challenge with engineers, right? So all right. So yeah, so that's where we kind of like struggled with use cases, and then like how do we understand all the nitty-gritty details, what could be the a lot of them, as it's kind of like a chicken and egg problem. So without me learning the OpenUSD, I can't apply, but then I see some of the use cases, but then I don't know how to do it, right? So that's when we said like, okay, so the other interesting thing was like, I was seeing some of these use cases done in like say entertainment, or even on the industrial manufacturing side or logistics that NVIDIA was showcasing. So I had a hard time understanding how to build these kind of things. So that's when I took this OpenUSD journey to figure out, okay, so I see a lot of parallels, and how I can apply, how I can take this OpenUSD that's being done elsewhere, and then how can I apply for specific to industrial inspection. So that was my thought, and then so so there were lack of use cases, and then Maddie helped us put together some kind of a basic tutorial. We started working on that. Aaron Luke shared his videos, so we started going through that, and then so the other important thing we started doing was like every week. I know Maddie was also running developer sessions on Omniverse on Fridays, but then there were some of these basic USD questions. So that's what we would ponder about as part of this weekly study group. So pick a specific topic on, let's say, variants, or the liver piece, right? So how does this how do we know within the scene composition which specific opinions are being expressed, right? So those were some of the challenges that we are trying to figure out, and that's how we started kind of like bisecting and dissecting, and then pick one topic at a time, and then start discussing about those. It's never done yet, so there are it's like OpenUSD is kind of like there's a lot to learn in that. So there are a lot of possibilities, specifically in terms of the big advantage with OpenUSD is like it's not a content creation tool, but I can bring all of these things and assemble it without destroying anything that was natively created, right? So and I think that's the biggest advantage we have, and I think it's going to proliferate into all industrial sectors, because there is a capability to visualize and then plan out a scenario. Think about like how these things might evolve, right? So if you were to think about it, so that is what OpenUSD is going to give you, that capability. So yeah, no, there are a lot of challenges, like say whether it's be understanding the variants, or understanding the primvars. How do I create a mesh, and then how do I specifically individual cells in a grid, how can I vary the color, how can I because a lot of the content we do see in the future is going to be procedurally generated as well. And I think understanding these basic mechanisms is key for us to get to these next level. So
makes a lot of sense. And Michael, is this kind of where do you see things going from here? And why don't you tell a little bit more about ThinkTwin and the work you're doing to enable this kind of tech for more people?
Yeah. Actually, I just got back from an industrial metaverse get-together event today, and like it was great to see the gaining momentum of OpenUSD adoption. So So there was like Mercedes, like Continental, KUKA, all these players come into the game, and you see that and everything like gets going, right? And it's all enabled by OpenUSD. So I think this is just great. Myself, we got into it from the BMW factoryverse efforts, and this was like the starting point to do our SyncTwin spin-off to just bring everybody into the industrial metaverse with OpenUSD. So I'm totally excited about it still after 3 years now. Yeah. So
it's awesome. Everyone should definitely be sure. Any companies looking to leverage digital twins for their work, you should check out SyncTwin's website, synctwin.ai. Will bring you right to his page. And Michael also is a great person to follow on LinkedIn. He's amazing. Always posting great information, great blog posts. And that's the other thing that's really amazing about the people that are here today, is that you're always sharing with the world. Nandu, Maddie, you're also people should also follow Maddie on LinkedIn. But you're all sharing, and Nandu, the information you presented today, such great kind of transparency and visibility, and celebrating over the technology for the benefit of other people to also learn and be able to leverage and use it to help their business grow. That's just amazing. And on top of that, helping manage the USD study group to get people together every week for the love of OpenUSD. We need to get a bumper sticker or something for you guys. But that's pretty awesome. I'm also really excited regarding OpenUSD. There's some great OpenUSD related activities happening at SIGGRAPH, which is coming up in late July in the United States. So for anyone out there who is in the Denver, Colorado, or it's not too hard to get to, I encourage you to come out to SIGGRAPH. It's going to be a great OpenUSD kind of events happening and get-togethers. We're going to have a lot more details to share. I almost let out too much a second ago. I had to bite my tongue. There's going to be a lot more we're going to be sharing very shortly. And let us know also if you are planning to go to SIGGRAPH. It'll be great to meet up. We all had a great time, and people here had a great time at GTC. Meeting up, and those kind of moments are just a really fantastic time to get together and network. Big thanks to Amelia for posting her chat, posting the link to Michael's LinkedIn page in the chat. Okay, so Kai, I wanted to also ask you. So you've been part of the OpenUSD study group for a while too, right? You've been pretty regular for about how
basically
long?
every time I can make it. I think I missed first 2 or 3 sessions when it gets started, but yeah,
that's awesome. And tell me, so if there are people watching here who are thinking about, oh, maybe I'll check it out, what's your pitch for why do you keep going? What do you enjoy about it?
well, basically my driver for OpenUSD is that you can make everything with it what you want. Basically, I like to call it JSON of 3D. So I can incorporate any information I want into a USD file, and then can use it for the default inspection or visualization features, but I can store any meta information in the background I need for my industrial application, for example.
Very cool. And you said your company's based in Germany, correct?
Correct, yeah.
Okay. And are you focusing on a specific industry or?
Yeah, the company makes grippers, vacuum grippers to be specific. And
wow.
Yeah, now we're trying to make some of our gripper models available as USD files for people to play with them. Yeah.
Very cool. All right. And then the last question I want to ask everybody, we try to do this when you have these kind of discussions, is like, what's next? Where do you guys see things going from this point on? Obviously, as I mentioned earlier, there's been a really big momentum with adoption. So where do you see this all this kind of translating to for real world usage? You start with Nandu. Nandu, where do you think things are going?
So yeah, I mean, we have at least another half a dozen or so, ideas in terms of, like, what type of application specific to industrial inspection. So one of the big challenges, or the I should say challenge, but the what can be addressed using OpenUSD is specifically, like, you can look at, in industrial inspection realm, you can look at a defect that's as small as, like, less than a millimeter, and that could be spread across few meters, or even over a distance of a kilometer, right? So OpenUSD gives us the ability to look at that level of detail, and you can look at it, and then you can do all kinds of 3D or spatial intelligence analysis that can be built using OpenUSD. And I think that's kind of like the holy grail, I would say.
Yeah, that's yeah, it makes total sense. Kai, where do you think things are headed?
Well, I think it will spread further because right now we don't see that much adoption, but yeah, I think it has a huge potential, and hopefully we will see more applications using OpenUSD.
Yeah, I think clearly, I think the companies that we've been talking to and seeing in at different events have been really most impressed by the prospect of interoperability, which is really, I think, the main struggle a lot of companies have with their different pipelines. Maddie, where do you think things are headed?
I see two areas. One is large scale digital twins. So being able to assemble lots of 3D data and non 3D data into and being able to see that in high fidelity is one part, and then the other part is like we were talking about is 3D generative AI, and we're going to want to see large scale things like that. We're not going to want to build it out all by hand. So leveraging generative AI to get there.
Makes perfect sense. In the end, there's, I think, never been so much excitement for Gen AI as there is now. We've just this morning, there was an NVIDIA webinar on how to learn and get involved with generative AI for students or for people who are looking for, to advance their career in this area. There were thousands and thousands of people registered. It's crazy. I mean, the live chat was insane. So really surpassed all expectations. So yeah, so that's it's a good sign of people's excitement. Michael, so where do you think things are headed?
I'm also on the generative AI side and also non 3D data, and this coming together with semantics in order to exchange also non 3D data. So but yeah, generative AI, I guess.
Yeah, makes total sense. Well, gentlemen, the hour has flown by. I want to thank everybody for participating, most especially Nandu for preparing the great material and the presentation, and for sharing so much background and insight into how your company works with OpenUSD, and also showing everybody what industrial inspection is and how important it is. So funny when you learn about these things that you never knew existed before, but they're also so pivotal and so crucial. So thank you. I'm sure you've inspired many people to dive in and learn. And for those want to out there who are listening or inspired to learn a little bit, it's about OpenUSD. We posted some resources in the chat. We'll add them to the description afterwards. I highly recommend you consider joining the Omniverse Discord server, where we have a great community of people across different channels, and also the study group, which meets there once a week. There's also a cool little job board and a showcase channel where you can check out some people's work if you want to be inspired by others. But thank you all very much for joining us today. I'm going to close out the live stream with a short Inception video, because I think that Inception, as Nandu mentioned earlier, is just an amazing program that NVIDIA has for startups. So if you're involved in a startup or know someone who is, I highly recommend Inception. Michael, are you a member of Inception?
Yeah, it's great. It's totally recommended. Yeah.
Amazing. All right. Well, we'll close out the live stream with this video, but thank you everybody for joining us today.
Thank you so much.
Yeah. Thank you, Nandu. And
Yeah.
we'll see you all on Discord or on the forums on the next live stream. Thanks for watching.
Yeah, thank you.
Thank you.
Bye.
NVIDIA Inception is partnering with thousands of the world's most innovative companies. Startups at the forefront of AI, data science, gaming, and other breakthrough industries. NVIDIA Inception is the free program that empowers startups through every stage of their life cycle. Learn how you can fast-track your path to success with these program benefits. Accelerate your growth with credits for technical training, online forums, and expert guidance. Jumpstart your development in the cloud, on-prem, and at the edge with over 150 NVIDIA SDKs, pre-trained models, cloud credits, and preferred hardware pricing. Explore funding opportunities and introductions through the NVIDIA Inception VC Alliance, a community of investors excited to connect with you. Strengthen your startup's visibility through exclusive events, speaking opportunities, and promotional support.
NVIDIA seems to be one of the few, if only, companies building a robust startup program.
No matter what your size or funding stage, NVIDIA Inception can accelerate your growth. Join our global community of innovators today to see what's possible.
Thank you again for watching. If this live stream has been helpful, inspiring to you in any way, please like and subscribe. It really helps others notice the video as well and learn. And subscribing will let you see when our next video is live. Thanks again to our special guests, Nandu, Kai, Michael, and Maddie, and Dr. Singh, of course. Really great hour. And thank you all for joining us today. It's been a great pleasure. Until next time.